Kirchhoff's voltage law, or KVL, applies to voltages around a loop. But before I get to the details of the law, let me define what a loop is. Well, as it turns out, a loop is just a path that starts from a node and comes back to the same node without passing over any of the nodes twice. The definition looks complicated, so let me show you an example and show you how straightforward and simple it is. So in order for you to draw any loop, what you need to do is you need to define a node or start from a node. And from this node, you just basically go on and just tells me like, okay, this is another node, and then here, and then here, and then here. So what I did is I started from one node and I drew a path coming back to the same node without passing any of the nodes along the way twice. So here's another example of another loop. So obviously you can see that there are 4 loops that are straightforward. You can do this. This is simple, but I'm going to show you something a little bit more interesting and complicated. So for example, I can just say this is a loop, okay? And you can come back in here, and you can come back in here, and you can come back in here, and this is another loop. What I did with this particular loop is I started in here, and I passed all these nodes around the way, but I never passed anything twice. So the pink one and the blue ones are completely 2 separate loops. So what you need to do is in order for you to apply KVL, you need to define a loop, and based on that loop, you can just basically the algebraic sum of the voltages around that loop is 0. And you can define as many loops or how many loops you want, and it can be complicated. For example, here's another example, just so that it's not overcrowded. Let me just delete that. So here's another example. You can start by saying, you know what, I want to do this with this one in here, this one in here, and this one in here, and then this one in here. So that's a loop. Okay, obviously this is not a loop. Let me just show you. So for example, let's assume that I wanted to come in back in here. So what happens, like if I go back in here, what happens is I hit this node twice. So that's not a loop, and I didn't reach the original. So that's not a loop. Okay, so you need to make sure that you start from any node that you want. As long as you don't hit a node that you've seen before, okay, that basically becomes a loop. All right, so what does KVL tells me? Well, KVL tells me is the following. KVL tells me that, that if you have a loop, so I'm going to focus on this particular loop in here. Okay, let me just draw it. So we have this particular loop. And typically, we don't highlight it with a highlight. What you will see me doing is you will see me doing the following. You'll see me saying, well, this is a loop, okay, in blue, and there's some sort of a direction of the way I'm going to go throughout the loop. I'm just going to draw it back in here, okay? And this loop in here has 3 different elements. I just copied and pasted in here just so that we can focus on this particular loop only. So what I will do is I'll define the voltage around that loop. So I'm going to say, well, I have plus minus the source in here. That's, I'm going to call it Vs. I'm going to say plus minus, and this is V1. And I will say, well, this one here around this particular resistor, I'm going to say this is the minus, this is and this is one here. I'm going to call it V3 because there's an R3. So what this loop tells me, or what KVL tells me, is the sum or the algebraic sum of the voltages around a loop that I defined should be 0. So how do I write this? Well, I'm going to write this particular equation with this particular loop and in this particular direction. So I'm going to go in here. You're going to see that I hit the voltage V1. I had the positive first. I just will say plus V1. And then the next one in here, I'm going to sum it. And the one that I hit first while I'm going through this loop is the negative. I'm going to just say this is negative V3. And then I continue and I just say, well, okay, I hit the negative port first here for negative Vs. Okay, equals 0. This has nothing to do with the passive sign convention. There's no current in here. I'm just going through this particular loop and I'm just summing the voltages, but some of the voltages are high, low. Basically, I hit the high before the low in this particular case in here. And in the second case, I'll hit probably the negative before it. So I just go through it and I just sum them. So that's what we do. So that's what KVL tells me. Of course, I would have been able to do the same exact thing by looping in the opposite direction. So let's assume that I'm going to write it in red in here, that I define the loop in the opposite direction. It's exactly the same thing. So for example, I'm going to start with the V1. You'll see because I'm in here, I'm hitting the negative first in here. So that's actually negative V1. Okay, and then I go back in here and you'll see that the Vs, I hit the positive. So that's plus Vs. And then I come in here and I hit the positive with the VR, it's actually, or V3, and that's basically positive V3. If you take a look at these 2 equations, you'll see that they're equivalent. Algebraically, they're equivalent. You just multiply by -1 and you'll get that. So the positive becomes a negative, the negative in here becomes a positive, and the negative in here becomes a positive. They're the same exact equation, and that's what KVL. So you can write this across any loop you want. Whatever the loop you like, it's exactly the same. It's exactly the same procedure. You just define a loop, you sum the voltages around that loop, and you figure out what KVL is. Well, you figure out that equation, and that you can use that equation in solutions. So going back to this circuit that we've seen before, we can define, if you remember from the KCL video, we needed a couple more equations in order for us to find or solve the circuit. We had KCL gave us 2 equations, Ohm's law gives us 3, so we need 2 more equations. KVL will give us these 2 equations. All right, so we need to define a couple of loops to write KVL equations for. So I'll define them, and you can have any 2 loops you want. I will have one, for example, let's start with this one here. I'll just basically take the outer one in here. So I'll just basically define this as loop 1. And I'll define the other one inside. For example, I can just define this one here, and let me just select a different color. For example, I can just say this one here is loop 2, this particular one. I could have just easily selected this loop 2, but I just selected these. It doesn't matter which loops you use. All right, so let's figure out for loop 1. Okay, so loop 1. So for this particular loop, I'll just start from here. You'll see that basically I hit the negative port for the V1, so it's negative V1. And then coming back in here, you'll see that this loop actually, let me just do this. I hit the positive V3, so that's positive V3. And then I go back in here. I don't see this loop because it's not part of the loop. It's not the part of the path I just drew for the loop. So I'll have to continue, and you'll see that I hit the negative 20 or the negative VS. I can write it either way. I can just say, well, negative 20 or negative VS. It's up to you. So we're going to write it negative VS, and I think that's it for the loop. That becomes a 0. So negative V1 plus V3, negative VS. Of course, you could have written it the opposite direction. Like you could have like easily said, well, let's go that way. You'll get pretty much the same type of equation. All right, so let me just do this here. I'll just write it 20. That's fine. Either way, you can either VS or V20. All right. So how about loop 2? All right, loop 2 in here. I will take a look at it. Well, loop 2, I'm going to start from this, and you can start from any voltage. It doesn't matter. You can start here, here. It doesn't matter. At the end of the day, it's a loop. You're returning to it. So I'm going to start from here. That basically tells me that it is negative V1, negative V2, and negative 20 or negative VS. It's up to you. VS equals 0 or negative VS. Of course, I can rearrange these since all of them are negatives. I can just say V1 plus V2 plus 20 equals 0. So I had just generated 2 more equations using KVL. So KCL, KVL, and Ohm's law, I combine these equations and I solve them, and I'll be able to figure out all the voltages and currents across this particular circuit along with any power I need, and I'll show you this next.